So this is question B from the contest yesterday, which is round 1102. And what it's asking is you're given an integer n and you want to find two values a, two positive values a and b such that a is a palindrome and b is divisible by 12. And what a palindrome is that if you is that it's a number where if you reverse the order of the numbers, it's going to be the same. So for example, 131 is a palindrome because if you reverse it, it's going to be 131 again. Uh, 3443 is also a palindrome. And so, and all single digit numbers are palindromes because you can't really flip them. And if you like figuratively flip them, they're going to be the exact same number. So let's look at an example, 310. 310, wait, that's a pretty difficult example. Yeah, let's just do 310. And let's just look at what the answer gives us. It gives us 262 and 48. And we can verify this works because 262, if you flip all the values, it's still 262. And 48, if you do modulo 12, it's going to be equal to 0. So 48 is divisible by 12. So what we can first realize is since we want a plus b to be equal to n, we can do b is equal to n minus a. And another thing we can realize is since b is divisible by 12, n minus a also has to be divisible by 12. And if n minus a is divisible by 12, that means that n minus a divided by n minus a modulo 12 is equal to 0. And if n minus a modulo 12 is equal to 0, then n mod 12 is equal to 0. And n mod 12 is equal to a mod 12. And now we have to think of all the possible values that can result from modulo 12. And in the previous video I explained that modulo just means the remainder of if n divided by 12, what would the remainder be? And now let's just think of all of the remainders we need. And all the remainders we need is in the range of 0 to 12, or 0 to 11, I mean. So now we just have to find palindromes such that a list of palindromes as small as possible so that those palindromes modulo 12 is equal to, so all these numbers are fulfilled so that a palindrome modulo 12 is equal to one of these numbers. And the easiest way we can start doing this is by listing out all the single digit integers because they're really small. And if a number, if n is bigger than any of these numbers, then n won't be able to find any more numbers that work. So we always want to check the smallest values. And from here, we can see that this fulfills the range of 0 to 9 because 0 modulo 12 is 0, 1 modulo 12 is 1, 2 modulo 12 is 2, and 9 modulo 12 is 9, so it's in this list. And now we just have to find values, palindromes such that that palindrome modulo 12 is equal to 10, and another palindrome such that its modulo is equal to 11. And the easiest values are 11 and 22. So all we have to do is check each of these values, 0 to 9 and 11 to 22. We subtract it from n and we check if for any of these values n minus this value is divisible by 12. And since it contains all the modulos, if none of these values work, then we just know that n won't work. So now we can look at the code. And the code is pretty simple. I create values integer n and I take in the value n, and yeah, I don't really need this this variable right here. I don't really need it. I don't know why it's there, but we can just remove it. It's because like during the contest, I used the same answer, but my code was kind of messy, so I just changed my code before showing the code, and this code is much more cleaner. And basically for a, I just put in all the values from 0 to 22, from 0 to 9, and then 11 to 22, which is what we showed here. And then for each value in these variables, I check if n is greater than or equal to that value first. And then I check if n minus that value is divisible by 12, and if it is, I print it, and then I can break from the loop. And at the end, if I didn't find anything, I'll just put -1 minus -1. And I'll show you my code for the competition for the contest. It wasn't it was really it wasn't clean at all. It was really like I don't know what I was doing here, but it worked. But this code is pretty messy, and this code just gets the question done way easier. And yeah, I just submitted it to check if it actually works. Wait, yeah, I just submitted it to check if it actually works, and it does. So I'll put the code in the description, and I'll talk about question C tomorrow.